Hey guys, how's it going? Welcome back. In the previous video, we looked at the Haber process, the manufacture of ammonia from hydrogen and nitrogen gases. Okay, so we were investigating using these basic questions, how to balance chemical reactions. Okay, and we did that for the Haber process. And in this video, we're going to do for the contact process, and then hopefully we'll also do the same for the process of photosynthesis and respiration. Okay, so the contact process, in the first step, what we do is we manufacture sulfur dioxide. So we have sulfur. First, it'll be just sulfur in solid form, and then you have oxygen, and then you have sulfur dioxide. So sulfur dioxide would be, as in it's dioxide. Okay, so sulfur dioxide would be like this. So as you can see from this reaction, our equation is already balanced. Okay, so you have sulfur here, how many atoms? It's simply one atom. Here you also have one atom. Oxygen, it exists as a gas. So whenever you hear oxygen, it's just oxygen gas if the reaction is happening at room temperature. Okay, so it's normally oxygen gas, O2 here. And on the right hand side, we also have O2. Okay, so it's kind of balanced. Not it's kind of, it's really balanced. Okay, and the next process, so this one would be step 1. We're going to look at step 1 and step 2. So if you see in your textbooks, they won't balance this because it's already balanced. Okay, the number of atoms of each element is the same on each side. Okay, so then the next one would be sulfur dioxide. You have to take sulfur dioxide, then you react it with oxygen again. This time we'll get sulfur trioxide. Okay, so sulfur trioxide would be like this. If you're doing chemistry, then you should know that sulfur here and here they have it has different valencies. Okay, so sulfur is capable of having different valencies. Okay, but that's an aside. If you're doing combined science, you should just know how to balance this. So there are two ways to balance this equation. So you can go one way is to just recognize first that sulfur and sulfur, there's one atom, so yeah, sulfur it's kind of balanced, it's balanced really. And then oxygen, we have 4 here, but then here we have 3. So if your math is really good, you can actually adjust this one. The opportunity for balancing the equation, it's with oxygen. Okay, I told you that whenever you see an element, or whenever you see a molecule that is the same element there, so for example hydrogen, for example oxygen, those are your best opportunities for balancing equations. Okay, so you should look out for those. So here, so it's O2, so I can make this one, I only need, already I have 2 here, I need to make it 3, so I can make it half. Okay, if it's half, that means I only have 1 oxygen here, then plus this 2 oxygen molecules, then I actually have these 2 oxygen atoms, then I actually have 3 oxygen atoms, just like on the right hand side. So my equation will be balanced. And notice that the way that I did it, I actually didn't disturb the sulfur, which was already in balance. So if your math is really good, then this is a brilliant way of balancing chemical equations. And then obviously, just like we talked about in the previous video, you have to balance using whole numbers in your stoichiometric coefficients. Okay, so here we'd have to remove fractions. We'd remove fractions by multiplying throughout by 2. So this one becomes 2 SO2 here plus, then this one just becomes O2, and then this one now becomes 2 SO3. And then obviously you have to double check sulfur in check, so we have 2 sulfur atoms, so which is good. Is oxygen in check, so we have 6 here, and then we have 4 here plus 2, this 2, it's 6. Okay, remember this 2 coefficient means you have 2 atoms here, you have to multiply them by this 2, so you get 4, then 5, 6, then here you have 6. So yeah, it adds up, it's in balance. Okay, so this is one way to go about it. I'll show you the other way. So you can just choose. If your math is really good, then you won't have a hard time understanding this. But if your math is kind of janky, it's still fine. I'll show you a way to achieve the same result here. Okay, so this is how you go about it. You have oxygen here. There's oxygen, you can see that's O2 here, This one is the opportunity again for balancing your equation, but then this one is even, so you have to make this one even as well. So the way that you do it is you'd start with this one, so make it even. How do you make it even? The lowest number that you can use is 2 here. So now you have 2 sulfur. Don't touch this one. This one is your greatest opportunity for balancing, so you're going to leave it for last. Okay. So here now we have 2 sulfur atoms. When we made this one even, so we have 6. So 3 oxygen atoms multiplied by 2, so we have 6 oxygen atoms. But then when we made this even, we actually disturbed the count for sulfur. We have to correct that. So go and correct for sulfur first. And what I want you to focus on, so sulfur would be 2 and then 2. What I want you to focus on right now is the fact that I'm leaving oxygen here because it's standalone. Usually the standalone elements are the elements that you want to finish with. Okay, because there's kind of flexibility with them. You can put any number here without disturbing the other ones. But then here, if you put any number, then you're also disturbing oxygen. If you put any number, then you're also disturbing oxygen here. Okay, so here, this one is the 2 atoms of sulfur, 2 atoms of sulfur, 4 atoms of oxygen. Here we have 6. So this one is it's also just one oxygen. Okay, so just 1 by 2. So this one it's 2 as well. So 2 here, then 4 here, then 6, then here 6. Okay, so your luck, you and luck. This one was balanced in just those 2 steps. There's 2 steps. Okay, we're not going to do the third step. The third step is the manufacture of sulfuric acid. We are not going to do that one. Okay, instead we're going to practice. We're going to pick up one question from there, and then we are going to practice from for the photosynthesis process. So photosynthesis process would be, we say carbon dioxide plus water. We're going to this one is what we're going to finish with, and then it will be like this. Then you have chlorophyll and sunlight. So let me put sunlight here. I'm not sure the way that they put it. So chlorophyll, and then you have C6H12O6 like this. Okay, so this one is the glucose molecule, and then we have O2, obviously the oxygen, okay, that we get from photosynthesis. So we're going to practice balancing this one and then seeing how it balances, how to go about doing that. Okay, so before we do that, we may want to look at this one first. Maybe this one or even this one as well. It's still fine. But then they're kind of different here. Okay, so you have C2 H4O2 here. Okay, so here you have C4H6O3. So here what you can do is to count the number of oxygen or number of carbon atoms first. So here it's 2, here it's 4. Okay, so this is non-routine. There's no one way to do it. So the way that I would go about it is to just put a 2 here on a rough piece of paper, and then just see how it checks out. So this one would be 4 here, then this one would be 4 here, this one would be 8 here, then this one is 6, then plus 2 here, so it's 8, and then this one is 4 here, then this one is 3 oxygen atoms, then this one it's the other one, so it'd be 4 and 4 oxygen atoms. So already we balanced our equation just in one step. Okay, so I thought that this would be similar to the equation that we're going to do for photosynthesis, but it's kind of different. Okay, so this one you actually balance it in just one step. Yeah, this one we can also try to do it. Here the catch, what I would do is to recognize that this anion, so this one is SO4, it's if SO4 2 minus, it's recognizable, especially if you're doing chemistry. So this anion here, we have 3 of these, so we actually need 3 of these as well here. So I can start by balancing them. So balancing the SO4 and our anion, so I would put 3 here. So here they'll be in balance. Okay, so and for iron it's just 2 here. So I would want to put, I would be tempted to put 2 here. Okay, my faith is in this being this in this way. Every reaction that occurs in nature, it can be balanced. Every reaction that occurs in nature can be balanced. So it's just a matter of playing around with the numbers and finding the minimum ratio possible that you can use. Okay, so here would be 2, and then what we did was that we upset the one for bromine. Okay, so bromine, it's 6 here, but then this one here, it's just 1. But then when we upset the one for bromine, we also upset the one for hydrogen, because here bromine is attached to hydrogen. So we have to make sure that whatever we put here, it has to balance for the 2 here, for bromine and also for hydrogen. So hydrogen is already 6 here, bromine is already 6 here. So you can just go ahead and put a 6. And that's it. It's balanced, and then use stoichiometric coefficients. There are 2, 3, 1, and 6. Okay, so 2, 3, 1, and 6. So it's already balanced just like this. Okay, so it's sort of non-routine. Balancing a reaction, it's non-routine. You get better by just working out as many questions as possible as you can. Okay, so this one went well, and what we're going to do now is to just go straight to our equation on photosynthesis. Okay, and then try to balance it out. And also notice here, just in passing, the last molecule that we actually balanced was this one. Okay, so if you notice, it's kind of the molecule that is least crowded of all of them. Okay, so last time we were saying if you see standalone elements or you see standalone molecules, those are good opportunities for balancing chemical reactions. It's also the same thing here. If you see that it's too crowded, for example, if you put a number here, you'd actually change so many things, because you're changing iron by a multiplier, changing sulfur, this SO4 2 minus by another, you're changing by another factor again. So it becomes difficult. So you just leave this one there and then balance this one at the end. You get the best chances of balancing your chemical equation. Okay, so for this one, what we do is recognize that this one is the most crowded one. So we can actually try to avoid this one, and then intuitively this one would be the last that would balance, because it provides the best opportunity for balancing this equation. It's just a standalone molecule, it's just oxygen. So if we upset oxygen along the way, just balance everything out, then we have an opportunity to actually correct for this with this molecule here. Okay, so the way that you go about it is, this is C6, so I would start by balancing the carbon. So carbon, now we have 6 and 6. 6 on 6, it's good. Okay, so hydrogen, here we have 12. So here we have just 2. So you can actually correct for this one. 2 atoms, so you need a multiplier of 6, such that this is 12, so that it balances with this 12 as well. But then see, the ones for oxygen, this one is 12, so as in 2 atoms multiplied by 6, then you get 12. And then this one is 6, so you actually have 8, 10. Okay, so you have 12 here, and then you have 6 here, so you actually have so let me actually write this one down. So 12 oxygen, so 12 O here plus 6 O here. Let me try to do it like this. Okay, is equal to, then here we have 6 oxygen here, and then we have an opportunity to balance this out. Okay, so here we have 12. You'd say you have 18. Already 6 are taken, so we just left with an opportunity of 12 here. In other words, we want to make this 12. This one is 6. We want to get to 18. This one must be 12 somehow. There's already 2, so in order to make it 12, you have to multiply by 6 here. And this is an equation for photosynthesis. An equation for respiration would be the opposite, so it'd be like C6H12 O6 like this, then plus 6O2. Then you have carbon dioxide O2 plus 6H2O. Okay, so this one is essentially the same equation but in reverse. So just like photosynthesis and respiration, they're like the reverse of each other. Not in the reverse sense that we're talking about with the Haber process. A little bit different, But then this is essentially it. So thanks so much for watching. This was fun. So I'll catch you in the next video. If you have any suggestions, obviously, just put them in the comment section, and then I'll try to attend to that. Thanks so much for watching. Our channel is growing. We really appreciate it. So cheers, Yuba out.